Another always, sometimes never. In problem 3.3.1.4, we want to show that, or decide if it's always, sometimes, never the case that if you have a symmetric matrix and you multiply it by a scalar, the result is a symmetric matrix. I think it's always the case, so I'm going to try to prove it. And I started by thinking of the matrix A multiplied by beta, calling it C. And I know that in order to talk about a matrix C being symmetric, what I needed to do is look at the entry in the jth entry and show that it's the same as the entry ji. So I look at the entry in the ith row, jth column, and show that it's the same as the entry in the jth row, ith column for all I and j. So let's look at the entry in the ith row, jth column. Well, again, C is found by multiplying the matrix A by this scalar beta. So this entry is just beta times the entry in the ith row, jth column of A, which we usually call alpha ij. What do we know about A? A is symmetric, which means the entry in the ith row, jth column is the same as the entry in the jth row, ith column of A. So this gamma ij is actually equal to beta times alpha ji. Well, we know that if we take beta times alpha ji, that gives us the entry in C that's in the jth row, ith column. Since again, C is beta times A. Okay, that means that for all I and j, the entry in the ith row, jth column in C is the same as the entry in the jth row, ith column of C. So C is symmetric. So it's always true.